Hi, so let's look at some of these problems that show up on the checkpoint for the similarity transformations. All right, remember to think about our awesome test taking skills that we've been practicing with some of these checkpoints. We definitely want to automatically cross things off that we know aren't true, draw pictures to help us. Those are those big tools. So let's look at this one here, for example. In coordinate plane, DEF has these vertices. So let's just draw ourselves a picture to understand what these look like. So we draw a coordinate plane here. D is at 1, 2, 3, -2. There's D. E is at 5, -3. E. And then F is at 4, -4. There is F. Cute little triangle. All right, GHI is at 5, 5, 3, 4, 5, -5, 1, 2, 3, 4, 5, 0. That's H, G, and I is at 0, -3. So there's I. All right, you can see the two triangles here. It says select the sequence of transformations that can be applied to DEF to show that it is similar to GHI. All right. Well, one of the big ones with similar ones is a dilation. So if you look at this, we start with a small triangle and it ends up bigger. Remember what we talked about with scale factors. If it starts small and gets bigger, that scale factor has to be greater than 1. Well, if we look here, a dilation of a scale factor of 1/5? Heck no, that's going to make it smaller. Same with the next one. That's going to make it smaller. So those two are automatically not correct. Come on. There we go. So it's going to leave us with just having to check the bottom two. So that's a lot less work. All right, so let's pick a point. Point G here. Let's start with D. And remember the way it's written here, DEF is similar to GHI. That means D and G must be corresponding vertices. So point D should become point G. So let's check point D. Point D, as we mentioned, is 3, -2. All right, so we want to do a translation left 4, up 3. So left is negative direction and up is positive. So our new point, 3 minus 4, would be -1. -2 plus 3, a +1. All right, so that's the translation. Followed by a dilation centered at the origin with a scale factor of 5. So dilation, and remember scale factor of 5 means multiply each thing by 5. -5, +5. And then a reflection across the y-axis. Think about those rules we talked about in Unit 2 with reflections, rotations. If you need to get those notes back out from Unit 2, look up all those rules. It's a reflection across the y-axis. If you remember, it makes the x value, it changes the sign of it. So since it's -5, it becomes +5. So let's see, is that point G? It is. I think this one is correct. But just to make sure, I'm going to try the second one. So I start at 3, -2. That was my D. That's point D. Let's try these transformations. A reflection across the x-axis. So if I reflect it across the x-axis, remember that changes the sign of the y value. So it becomes 3, +2. followed by a dilation. My dilation, again, scale factor of 5 means multiply by 5. 3 times 5 is 15. 2 times 5 is 10. And a translation left 4. So subtracting 4 and going up 3, adding 3. So after my translation, it's going to be 9, 13. Is that my point G? No siree, Bob. Come on, draw the other line. There we go. So the only correct answer would be the third one here. And remember, a lot of times in IXL, there might be more than one correct answer, so it's important to check them all. But only the third one gave us that 5, 5 after that last transformation. So fingers crossed. Woohoo! All right, and keep in mind with these, you only need to get to 50. So with these checkpoints, you need to get to 50, and I completely understand these because they take very long. All right, so let's look at this one. We're going to complete the paragraph to prove that they are similar. So since P is congruent to S, first translate and rotate PQR to get P prime, Q prime, R prime, where, let's see, who coincides with S? If you look at the similarity statement, S is listed first, so P prime coincides with S. P prime, Q prime, notice PQ here. So ST must be the other one. Next, dilate P prime, Q prime, R prime about P with a scale factor. Remember, we want it to be old over original. New over original. So it's going to be ST over the original, which was P prime, Q prime. That means Q double prime. And if we look at our similarity statement, Q must be corresponding or coinciding with T. All right, translations, rotations, and dilations preserve angle measure. So P prime must be congruent to S. Remember, P and S are the coinciding ones. And Q must be congruent to T. That means PR, notice PR, first and third, coincides with first and third here, so SU. And Q prime, Q double prime, R double prime corresponds, notice QR, last two letters, TU, last two letters. Both R and U are at the so let's see, PR and QR, PR, QR. So R is at the intersection of PR and QR. And U is at the intersection of it. So R coincides with U. Therefore, triangle PQR coincides with STU. That means PQR can be mapped onto STU by sequence of rigid transformations and dilations. Notice we did both. We did a translation first, then we did the dilation. And again, totally use this figure to help you draw on there. I feel like I gotta close my eyes. Yay! All right. Another one here. A translation followed by a dilation centered at the origin maps the quadrilateral onto the new one. Find the translation rule and the dilation rule. All right, so the translation rule, we are starting at R. Which is 2, 3. Actually, it might help when we are finding the dilation. Notice how point S here is right at 0. So since we're dilating about the origin, let's start with point S. That's going to make it much easier because once you dilate, if you're dilating about the point right where the point is, it doesn't move. So notice S originally started out at 6, -5. So to translate it over here to S prime, I had to go 1, 2, 3, 4, 5, 6. So 6 in the left direction. And then I went up 1, 2, 3, 4, 5. So y plus 5. That was the original translation. And then, let me erase that so we can still see all of our points. All right, now to find the dilation. So originally, to go from S to R, I would go 1, 2, 3, 4 to the left, and then 1, 2, 3, 4, 5, 6, 7, 8. 8 up. That was originally to go from S to R. In the new figure, I would go 1, 2, 3, and then I would go 1, 2, 3, 4, 5, 6. So this is the new one. It's compared to the original or the old. So to find the scale factor, it is going to be new divided by old. So my new one in the y direction was 6. The old was 8. 6/8. Notice it says scale factor as a whole number or simplified fraction. So they want it as a simplified fraction. That would be 3/4, which again checks out from the x direction. Would again be 3, the new one, 4, the old one. So my dilation would be 3/4 x and 3/4 y. All right, I'm hoping they like my answer that way. All right, let's see. Yay, it liked it. All right, one more. In triangle ABC, the measure of angle A is 40. The measure of angle C is 75. Again, take a moment. Draw a picture. All right, so we'll just say A is here. This looks like about 40. We'll say this is C. Thank you, Peanut, is 75. Peanut. So remember we have triangle sum theorem that allows us to find the third triangle or third angle of the triangle. which would be, I believe, angle B here. 40 and 75. Can add those up and we get, I think, 115. So my third angle must be 180 minus the 115, which I believe is 65 degrees. So there is my triangle ABC. Which of the following triangles are similar to ABC? So similar has to have the same measurements. One that is 40 and 75. That'll work. 40 and 50. That's a no. I don't have any angles that are 50. So nope. 65 and 75. Yep, I got two of those, so that'll work. 40 and 65. 40, 65. Yep, that'll work. 50 and 75. I got a 75, but no 50-degree angle. So that's not going to work. So it's just the first, the third, and the fourth. Again, we had to have two angles that are similar. Yay, and I got a brilliant. Again, very similar one here. So hopefully that helps you out doing some of these checkpoints. Take your time, use those skills we've had of drawing on here. Cross things off that you know can't be true. Good luck.